大家好，我是 CNCF 公司的生态系统总监洪水晴。I'm the CNCF Director of Ecosystem, Cheryl Hung. This is a meeting for the vendors and operators within the Telecoms User Group. So to begin with, I would like to ask, who is here from an operator? So please raise your hand if you're from telecom operator. Okay. And how many people from vendor? Okay, so probably 2/3 vendor, 1/3 operator. And then if you would like to say which company you're from, like just say it out.
Please.
No? What company are you from? China Mobile? Okay. Great. Okay, perfect. Well, with that, I'm going to hand over to Dan Kohn, who is the Executive Director of CNCF, and to Taylor. Go ahead.
Thank you, Cheryl. Ni hao. I'm not going to do any more Mandarin than that. We're very happy to have the kickoff of the Telecom User Group here in China. We had the first meeting a month ago in Barcelona at KubeCon Europe. Our goal, we're now doing 2 phone calls a month, as I'll show, and we have a document and other work going forward. We're also very open to doing Chinese language meetings if that is helpful, but we would like there to be a single telecom user group that is collaborating together around the world. That's really the whole point of our event. This is an out-of-date slide. We're missing our Apple logo on there. I will just mention the next in-person meeting we're going to have will be at the Open Networking Summit Europe, which will be in Antwerp in September. And we're going to have a half-day meeting of the Telecom User Group to try and move things forward. We'll then also be meeting in San Diego at KubeCon CloudNativeCon in November. I hope many of you can attend. So we're launching this group. It is similar to our end user community. You might have seen yesterday afternoon that Didi just received the award from Cheryl for being the top end user this year. We have 89 companies in our end user community. Apple is the newest one. The telecom sector is different. And so we want to allow both the operators and also their vendors to collaborate together in our telecom user group and to help try and document some best practices around how to run network functions on top of Kubernetes. I do want to say that the goal of this group is not to develop new software or even necessarily to develop new patches to the existing software. We want the technology work to occur upstream in the specific projects. But we do hope via collaboration to help be able to document the best practices. So some of the upstream projects that we need to keep track of, and there's a lot of them now, are Kubernetes Federation version 2, which is now being called KubeFed. And each of these is a link, and we will have these slides posted to the schedule so you can access them. Helm as a package manager and also customize, Envoy as a service proxy, the CNF Testbed, which Taylor is going to talk about in a minute, Open Policy Agent, which has a lot of interest, observability tools, Prometheus, FluentD, Jaeger, and now the newest one, Open Telemetry, service meshes like Linkerd and Istio, and I will point out that Istio is not, unlike the other things listed here, a CNCF-hosted project, Network Service Mesh, which is a very exciting but still very immature project. It's a new sandbox project in CNCF. Operators as a way of packaging up functionality, are the Kubernetes IoT Edge working group. And then finally, there's a link here to using Kubernetes as an inventory manager to keep track of all of the equipment on a network. So the kind of analysis that we want to do, the kind of work that we want to do here, as I said, is not coding, but things like gap analysis of talking about what are the solutions that are available today and what are they missing. There's particularly 3 areas around connecting VNFs and CNFs, Multis, DANM, and Network Service Mesh, talking about best practices for Cloud Native, for CNFs. And then one of the goals here is that if we are beginning to work on a white paper, that white paper would not just be a description of different approaches, but that we would actually implement those different approaches in the CNF testbed. And Taylor will talk more about that, and then be able to make real evaluations of the comparison. So at a very high level, we would say that the architecture in the past of NFV or virtual network functions has been, and particularly the first version of ONAP, ran on top of OpenStack, VMware, Azure, or Rackspace. You've now seen an evolution over the last couple of years, and with the current version of ONAP, that you can run it on top of either OpenStack or Kubernetes. Kubernetes lets you run on top of either bare metal or any cloud. And the evolution of where we think that this is going is to have CNFs, to have your open source system, your business support systems, all running on top of Kubernetes, that Kubernetes can be this universal abstraction layer. There's still going to be a number of legacy VNFs, virtual network functions. Those can run on top of KubeVirt, on Vertlet, on OpenStack, and then you can still have the ONAP orchestrator helping these connect together. And the Kubernetes can run on top of either bare metal or any public cloud or a hybrid combination. So this is just a phrase that I like describing a key aspect of the Kubernetes architecture. The entire system can be described as an unbounded number of independent asynchronous control loops, reading and writing to the schematized resource store as the source of truth. And as I talked about in my keynote, it's resilient, evolvable, and extensible. So I do want to emphasize one of the key thoughts for this group is about evolution. It's not feasible to throw away all the work that's happened over the last 100 years. The only way that CNFs can be useful to the telecom industry is if there's an evolutionary approach of taking the existing equipment, existing approaches, and helping evolve that to be cloud native. And it's really critical that at each step, that evolution adds value. None of your organizations are going to be able to make meaningful investments unless you can actually see the benefits in terms of resiliency, in terms of lower cost, in terms of faster time to market. Okay, I think I just have a couple more slides, and then I'm going to hand this off to Taylor. So there's one more kind of high-level thought that I would communicate here, which is imagine a physical firewall device that might have been installed 10 years ago in an operator's network. And then maybe 5 years ago, it was ported to become a VNF, a virtual network function running in a virtual machine. But really nothing else was changed about it. So now, if you want to take that firewall and make it a CNF, it's no longer possible to keep custom kernel patches or to use custom kernel modules. And the technology needs to be compatible with any kernel version 3.10 or higher that could run Docker. But that very minimal number of changes, what you could call a lift and shift approach of your firewall, doesn't actually get you that many benefits. And so particularly, you could call it, if we call this a bronze CNF, and there's an argument about this, that maybe we should call it a iron or a copper or something a very bad metal. But that you still have, you could have a completely proprietary management interface You might even need like a Windows PC running a special application in order to configure it. It can have stateful storage using a completely proprietary, opaque format. It may have no support for horizontal scalability to be able to go across multiple machines, no support for vertical scalability to be able to go to larger or smaller machines, no support for automatic configuration, and then a completely proprietary installer. So this is kind of the worst case for a CNF. And I mean, it's still CNF in that it is a container and it is something that can be orchestrated by Kubernetes. It's not clear that this generates very much value for in the real world. Then you have the other extreme. We'll call this a gold CNF. And the idea is that this is a set of best practices about how you can implement the network functions. So it should be compatible with any certified Kubernetes implementation. We now have, I believe, 89 of those. It should be stateless so that it can scale horizontally, store its state in a database or another service. It should be able to run unprivileged to be more secure. I mentioned the scaling support, configuration, and lifecycle. So it should be upgradable. It should be configurable using standard mechanisms. Observability is key in terms of monitoring and tracing and logging, supporting all of these projects. Installable and upgradable. And then to the degree it needs custom hardware or could take advantage of it, there's a standard ways that it should be accessing that. So we would like to engage with you. That's a very rough draft of what a bronze and a gold could be. And we do want to try and define that more. We'd like to engage with you. And one of the key ideas would be to define a silver CNF, to define something in the middle that's good enough that it's adding value, even if it's not perfect in every way. But you could imagine in a couple years that China Mobile and other carriers might start specifying that you need a silver CNF as part of an RFP. Okay, so I think I'm going to just very quickly mention here, there's a lot of different approaches on networking. There's a lot of different approaches on security. There is a ton of progress that has been made here that people are doing PCI Level 1 and HIPAA and ISO 27001 using Kubernetes. That micro VMs are a useful technology that people are investing in, but it's not at all clear that those are necessary or useful in a telecom environment. And with that, I will hand it off to Taylor, and maybe if we can do like 5 or 10 minutes and then leave 5 or 10 for questions. Thank you.
Yeah. Okay, so this is a...
who are you?
I'm Taylor Carpenter, Vulk co-op, and I'm leading the CNF Testbed initiative. So this is one of the initiatives related to the Telecom User Group. This would be the project that's also trying to complement existing projects. So there's a lot of other initiatives to build testing platforms and softwares at different level, and this is there to complement those. So this is on GitHub, and the idea is to provide examples in a code base that's completely open source that anyone can download and see what maybe an existing use case that you use as a telecom operator. You have use cases where you may have SROV network functions and firewalls and other things, and you want to show how they work together, and you want to collaborate with others. So this is an area where you can download the software and test, and we do that by using Packet. That's there on the bottom. Packet's a provider that has bare metal servers, and if you have a API key from Packet, you can download the software from GitHub and you'll be able to test those. So this is one of the examples of a test case that we've done, and this is focused on performance testing, and this is more of what is the base level so that you can try more complex scenarios. At the top, we're showing we're able to deploy OpenStack clusters on Packet and deploy some VNFs. What this is IP routers, so very simple, and that would be something that you would put in a service chain, a set of network functions. And we send the traffic through those, and they loop back out, and we check the throughput, the packets per second. And then we show the same sort of thing on Kubernetes. We're also on the bottom area, we're showing what you can do, which is currently just available with containers. You can do these MEMIF interfaces, so we can directly connect, and this is on one physical node, one physical machine. You can directly connect the network functions via memory interface, and then we look at what the throughput is on that. So this is some of the testing that we've done, and this is something that could be applied to any type of network function on the per machines. We also support multi-node, machine to machine, but we're doing different type of example test. This is just some more stats on the comparisons. And what we're doing is testing performance things like this to verify that you're going to get the performance that you would have expected when you were running it as a VM, a virtual network function, that we can meet or exceed those, and then build out the more complex use cases. So going back here, for anyone that wants to participate, similar to the Telecom User Group has white papers and documents that you can contribute to for understanding. The test bed is about contributing code and real examples that you can go in and understand. So if you create an API key on Packet, you can download the code and you'll be able to recreate it on Packet. The code is portable. We're trying to make it where if you wanted, you could take pieces out and test on your own lab equipment at different levels, whether that's deploying the Kubernetes cluster or setting up the network or deploying the actual CNFs. Most of the CNFs were originally based on some ONAP code. We're starting to get more contributions. There will be some other talks today about network service mesh in this week. We're hoping at the Belgium Open Network Summit to demonstrate a use case using network service mesh on one of the use cases and doing some SRV. And then future use cases, we're looking at to show a hybrid type of configuration where you may have an OpenStack cluster running a VNF from a vendor that they haven't even gone to a bronze, as Dan was saying, and you need to be able to connect to that. We're going to be showing a Kubernetes cluster running and clients connecting over a tunnel to the VNF and some other stuff like that, so that you have that migration as you're moving forward on your platforms. Let me see. I think some of these are principles. We have a lot of other information in these slides once we upload them that go into specs and stuff about the actual machines on that Packet that we're testing with, and we go into some of the challenges. This goes into stuff like the gaps that Dan was talking about. What do we need in the platforms? What's missing? What's there? There's a lot of solutions trying to add pieces around the device plugins and other stuff. So we want contributions both in code to test new examples, as well as to the different white papers that are in progress. You think that's probably about good? Maybe we could switch to, I don't know where the Q&A slide is.
Do you want to just mention that it doesn't have to use Packet?
It doesn't have to use Packet, yes. So right now this is kind of an overview of the stages that we have, but this is to set up, if you wanted everything set up, what we have in Packet. So you've downloaded you're creating a top-level configuration, number of nodes, machines in your clusters, and then you can run some software that we have that'll provision the machines and go on. You can actually, if you were interested in using your own Kubernetes cluster, you could just skip down and jump right into the other parts. Maybe Q&A?
Yeah. Cheryl, do you mind?
Okay.
Yeah, why don't you? Thanks, Dale.
Okay, I would like to open it to question and answers now, and we can have a discussion within the group. So please think about if this is useful for what you're doing, introduce yourself and your company, and what are the challenges that you see.
Hey, I'm Rastisal Sabo from Pantheon Tech. Actually, we do some CNF deployments for some of our customers. I do not have any specific question, but maybe some additional information. If anybody is interested in CNFs, there is an open source project called Legato, which actually packages FDIO VPP into a Docker container together with an management agent, which provides some northbound API outside cloud native way of configuring the VPP. That's ready for anybody who is interested and wants to play with some CNFs. You can check it out on legato.io. Also, there is one more CNI which I would mention that is called Kohn VPP, which runs also FDIO VPP as a vSwitch between the containers. That can help you as well if you need to connect multiple interfaces towards the pods, and also it supports some simple service chaining between the pods.
Just quickly on the Legato. I think many of you have seen the CNCF Cloud Native Interactive Landscape, and it's available at landscape.cncf.io, and you can get to it from your phone. And I'll just mention that under the networking section here, we have Legato, which was the project. You mentioned a control plane management agent for FDIO's VPP, and then also I had earlier mentioned Danem, which is a project out of Nokia that provides access, connects essentially between CNFs and VNFs. You have Multus right here out of Intel, but Red Hat and others support it as a way of doing multiple CNI interfaces. And then Network Service Mesh is the very new project from some of the same people who work on Legato, I believe, out of Cisco and others, but that now is a CNCF sandbox project. And so and then CNI is the standard way of doing Kubernetes native networking, and also Open vSwitch is used in the CNF testbed. And so you can come in here and click there and then learn all about these projects. Oh, I'll also mention FDIO is now here, is used for a high performance data plane. So these are all very likely to become part of the solution, or at least to be evaluated as alternatives.
Dan, let me bring up a slide that's related to this.
Please.
So if it wasn't completely clear, one of the things with CNF Testbed is we're not saying here is one piece of software that you should use everywhere, similar to CNCF in general. It's saying there's many options and here's what they do so that you can pick the one that works. So the implementation that we have, the main examples that we have right now, this is what it's covering, but we could use additional software. So we actually do use VPP as a vSwitch, and this kind of goes over that, but we have, here's VPP right here as a vSwitch on OpenStack, and we use the VPP OpenStack plugin that connects the talking to VPP with Neutron. And then on Kubernetes, we have the equivalent of a vSwitch running both as a host, or you can run it as a CNF that runs just in a container on the system. That's for some of the use cases where we actually need what would be a vSwitch. We have some use cases that we're building right now that wouldn't have a vSwitch. It would be like a SROV gateway. Most of those are using VPP, and we collaborate with a lot of different projects. We're using NFV Bench for the traffic generator and T-Rex. And DPDK is used most places, although we'll probably be testing the Intel plugin for VPP and not use the DPDK. But essentially, if there's a project that looks like it could be a good solution for a use case, then we're interested in trying to build that out. Content VPP is definitely something that we were looking at early on, but it's platform. What we're not trying to do is build a product. We want to help the projects that are building something like Network Service Mesh has very extensive features. What we're trying to do is highlight the pieces for a use case for discussions, and that's a driver on like the Telecom User Group is white papers and documents to have discussions on how best we should go about it. But we'd love to have contributions from the other groups, and if you're doing something that's maybe a complex setup and you're wanting to highlight parts of it and how it would work, then be happy to work with you on that.
Taylor, could you pull up the CNF Testbed repo
Sure.
just to show the schedule for the tug call? Yeah, so this is inconvenient. I guess you got to click through. It's going to be 11 p.m. here in China, but we would love to have your participation if you're willing to stay up late to join us. And then we also do post all of these calls to YouTube if you have a VPN afterwards to access it. But these are all open meetings. We would love to have your engagement and participation. And then we also have a Slack channel and the white papers.
Yeah, there's a Slack for, it's TUG on the Cloud Native Slack. There's also a CNF Testbed Slack. And a lot of these projects that are on CNF, like NSM, you'll find those there. So please join if you're interested in the projects.
We need to stop there. We will be up here for 5 minutes, so please come introduce yourself, and we would love to have your involvement going forward. Thank you very much.